In this video, we are going to discuss matrices, SAQs, exercise 3E, section 2, third problem. If A is equal to matrix 3 minus 3, 4, 2 minus 3, 4, 0, minus 1, 1, then show that A inverse is equal to AQ, which is also a very important problem. So now how to find A inverse is equal to AQ? So actually from the given matrix A, finding A inverse is equal to A is one method. Given that capital A is equal to 3 minus 3, 4, 2 minus 3, 4, and 0 minus 1, 1. See, finding A inverse and inverse of matrix A and finding AQ, that is one method. Now here I am telling the alternate method. So what is that? Given matrix A, this is 3 minus 3, 4, 2 minus 3, 4, 0 minus 1, 1. Now to show that required thing, what I am doing is finding A square. So what is A square here? A into A. So what is the matrix A here? So 3 minus 3, 4, and 2 minus 3, 4, 0 minus 1, 1. So into the matrix, same matrix again, 3 minus 3, 4. So 2 minus 3, 4, and 0 minus 1, 1. See, multiplying these two matrices. So now what we get, which is equal to, see here, so multiplying first row, first column, 3 into 3, that is 9, plus immediately, minus 3 into 2, that is minus 6, and here 4 into 0, that is 0. First row, first column is multiplied. First row, second column multiplying 3 into minus 3, that is minus 9, immediately plus, minus 3 into minus 3, that is plus 9, and here 4 into minus 1, that is minus 4, so plus minus 4 here, and again first row, third column multiplying 3 into 4, so 3 into 4, third column, that is 12, and again immediately plus, so minus 3 into 4, that is minus 12, this is minus 12, and immediately plus, so 4 into 1, that is 4. So this is a first row, third column multiply. Again second row, first column, 2 into 3, 6, and immediately plus, minus 3 into 2, that is minus 6, and here plus 4 into 0, 0. Again second row, second column, 2 into minus 3, that is minus 6, and minus 3 into minus 3, that is plus 9, immediately plus, and this is also plus 9, and minus 4 into minus 1, that is minus 4 again, so plus minus 4. Again second row, third column, 2 into 4, that is 8, and here immediately plus, so minus 3 into 4, that is minus 12, this is minus 12, and immediately plus, so 4 into 1, that is 4, this is minus here, this is minus. So again third row, first column multiplying 0 into 3, that is 0, and immediately plus, minus 1 into 2, that is minus 2, and plus 1 into 0, that is 0. Again third row, second column multiplying 0 into minus 3, that is 0, and immediately plus, minus 1 into minus 3, that is 3 here, so immediately plus, and here 1 into minus 1, that is minus 1. So next again third row, third column multiplying 0 into 4, that is 0, and here plus immediately, so minus 1 into 4, that is minus 4, this is minus 4, and plus 1 into 1, that is 1, immediately plus 1. See, now we have to simplify this is. We have to simplify. So that is 9 minus 6. So this is A square is equal to, so 9 minus 6, that is 3, and plus 9 minus 9 gets cancelled here, minus 4, and here 12 plus 12 minus 12 gets cancelled, 4, and here plus 6 minus 6 gets cancelled, that is 0. Here minus 6 minus 4 minus 10, and plus 9, that is minus 1. and here plus 6, 12, 8 plus 4 is plus 12, minus 12 gets cancelled, that is 0. And here this is minus 2, and here 3 minus 1, that is plus 2. So here minus 1 plus minus 4 plus 1, that is minus 3. So simplified a square. See, what we have to show that a inverse is equal to a cube. But here we have a square. Now what to do that a cube is equal to, we have to find a cube. A cube is equal to, find the a cube, what I am doing is here, finding a power 4. Finding a power 4 is how much? Now first we have to find the a power 4. As per that we get a cube also. Find a power 4 here. So a square already we have 3 minus 4, 4. And 0 minus 1, 0 minus 2, 2 minus 3. Again multiplying with a square. So with the same matrix 3 minus 4, 4, 0 minus 1, 0, minus 2, 2 minus 3. Actually what we have to prove, a inverse is equal to a cube. So now I am finding in the alternate method a to the power of 4. What we get, we'll see that. So again first row, first column multiplying. 3 into 3, that is 9. And immediately plus minus 4 into 0, that is 0, and plus 4 into minus 2, that is plus minus 8. Again first row second column multiplying here, 3 into minus 4, that is minus 12, and immediately plus minus 4 into minus 1, that is 4, and plus 4 into 2, that is 8. So again same first row third column multiplying here, 3 into 4, that is 12, and plus minus 4 into 0, that is 0, and plus 4 into minus 3, that is minus 12. This is minus 12. So again, so the second row, first column multiplying 0 into 3, that is 0, and immediately plus minus 1 into 0, that is 0, and plus 0 into minus 2, that is 0. Again second row, second column multiplying 0 into minus 4, 0, and immediately plus minus 1 into minus 1, that is plus 1, and 0 into 2, that is 0. Again second row third column multiplying 0 into 4, that is 0, and plus minus 1 into 0, that is 0, and plus 0 into minus 3, that is also plus 0. Now third row first column multiplying minus 2 into 3, that is minus 6, and plus 2 into 0 immediately, that is 0, and plus 3 into minus 3 into minus 2, that is again plus 6. Now again third row second column multiplying minus 2 into 4, minus 4, that is 8, and plus 2 into minus 1, that is minus 2, and plus minus 3 into 2, that is minus 6. Again third row third column multiplying minus 2 into 4, that is minus 8, and plus 2 into 0, that is 0, and plus minus 3 into 3, that is 9. See, observe here, we get which is equal to, that is a power 4 is equal to, we are getting here 9 minus 8 after simplifying, this is 1, and plus 12 minus 12 gets cancelled, this is 0, and plus 12 minus 12 gets cancelled, this is also 0, and here this is 0, and here this is 1, again here 0. So now plus 6 minus 6 gets cancelled, this is 0, and plus 8 minus 8 here. So these two are also gets cancelled, that is 0, and minus 8 plus 9, that is 1. See what we get here, a power 4 is equal to, we get the unit matrix of order 3, that is I. So now we get a power 4 is equal to I here. Actually what we have to prove, a inverse is equal to a cube. So now here this implies, so a power 4 is writing as a into a cube. Can we write now? A power 1 plus 3. So that is a power 4 only, which is equal to I. Now to get the required thing, what I am doing is multiplying by a inverse on both sides. When you multiply by a inverse on both sides, the above condition, it becomes a inverse into A into AQ, so which is equal to I into A inverse. I into A inverse. See here, so now further what I am doing is, here considering A inverse into A, these two matrices product as one matrix into A power 3 is equal to I into A inverse. See, we have the properties clearly here. What are the properties we have? So we have the properties are, suppose A into A inverse is equal to A inverse into A is equal to unit matrix I. So any matrix, if you multiply with the inverse matrix, you get unit matrix only. And also suppose any matrix, if you multiply with unit matrix, you get the same matrix only. Using these two properties, here this is I, A into A inverse is I into AQ, so which is equal to I into A inverse. Using the second property here, A into I is equal to I into A is equal to A we are getting. Similarly, A cube into I and A inverse into I, also what we get? We get this is A cube and this is A inverse. So therefore clearly, so A inverse is equal to A cube. So that's why this problem very easily we can prove that by using this alternative method.